Hello, Alex here from Harper, joined today by Kris Zyp. Today we're going to share a little bit about 4.5 and the new capabilities of Blob Storage that we're including there. So I know this has been a big feat from the development side. What do you see as the kind of the key reason why we're building Blob Storage now, and what value are we looking to deliver with it?
Yeah, sure. Really a big driver behind this is that we've been uh, powering more and more significant websites, e-commerce sites, and doing a lot more with high performance web applications and in the web space. And that's really an area where you see a lot of both structured data with the traditional database structuring information that may hold information about product information, users, things like that.
Uh-huh.
And that can help drive the creation of content for the web, but also a lot of unstructured data, images and videos and things like that, as well as even caching rendered HTML. And all of that actually is a different paradigm than what you would typically use a database for. And that's typically things that are a lot bigger and can actually be delivered in different ways. And so blob storage has really unlocked the ability to handle that data in a more efficient way that is specifically designed and optimized for the delivery and handling of that type of information. And so that's really unlocked our ability to further handle larger chunks of data, which is kind of the main intent of blob storage.
Okay. So thinking of this, you mentioned e-commerce as a use case here, and we're really focused on web performance at Harper. So I'm thinking like I go to a product page, there's pictures there, there might be videos there. Are those the type of assets that we're looking to really utilize this capability?
Yes, exactly. A lot of these things, yeah, are larger pieces of content, and it doesn't necessarily make sense to try to put all of those in individual database records. And so we're really being expanding our ability to handle both the data that works in the more traditional structured format as well as unstructured larger data. One of the other things that goes along with that is that the typical way that we approach structured data in a database is it's usually very oriented around the idea that we are working with data in an atomic fashion. And that's usually a very important part of database transactions is that whenever we change data, interact with it, these are atomic operations, which is great for deterministic handling of structured data. But as it turns out, when you get into dealing with larger chunks of data, there's actually significant advantages to work with data in actually more of a streaming paradigm.
Mm,
And so instead of like, I'm going to have this entire chunk and that's always going to be held together with larger content, especially as you get into things like video, naturally, that's something that is streamed between servers and clients. And as it turns out, there's actually significant advantages to having that type of architecture throughout the whole system. And it even unlocks the ability to do things like upload a video, and as that data is streaming in, we can actually do the database transaction, record that metadata before that's even fully uploaded, and then allow other users to interact with that metadata and even start streaming that data downstream to other clients at the same time as it's uploading. This is kind of a technique that's
uh-huh,
often used for real-time
uh-huh.
video capture and delivery. And so that's actually is a very different paradigm from the way that database transactions typically work. And so by being able to combine both the power of tracking and
Uh-huh.
keeping metadata and information in a traditional database structure, as well as having streaming capabilities, being able to couple those things together really unlocks a lot of powerful capabilities in terms of what you often do in web applications, where you really do have to deal with both of those same types of things. It really fits into the Harper model of a fused integrated stack where you have both of those pieces of functionality in the same stack.
Well, interesting. So, like, I've seen those architectural diagrams that, like, when video is being live encoded, streaming in real time, like, those are some really complex systems. Are you saying that with Harper we can now simplify those?
Yeah. And there's often a lot more that's involved in like building YouTube than
Hmm.
simply
Yeah.
streaming data. But it really definitely does unlock the potential for dealing with these larger pieces of content within an existing web architecture.
Okay. So use cases, we got kind of this e-commerce use case, which really focus on web performance. Then we have the streaming use case. Well, do you see this other use cases for Blob that might be unique to how Harper can implement this?
Yeah, well, and maybe just to touch on one of the other things that we've actually really been using this a lot for is caching the HTML itself. So it's a common design that uh, you may have an architecture like a Next.js framework that is rendering pages and potentially accessing structured data again from a database to generate, product page or product listings. But there's a fair bit of computational overhead to rendering these pages, and so there can be significant performance benefits to, not only having the database local to drive that rendering, but then even being able to cache frequently accessed pages in HTML post-rendered format. And oftentimes those are, of course, rather large pieces
Uh-huh.
of unstructured data as well. Oftentimes, a sophisticated e-commerce site may have pages that are a few hundred kilobytes. That's very common. And again, like having that be, based around a blob format allows for very efficient handling of that type of information.
Uh, so you're talking about efficient handling, and I believe you guys have done quite a bit of performance testing around Blob. Is that right?
Yes, yes, we have been doing a lot of work around that. And the reason is, of course, the part of the whole idea of adding this functionality to Harper was to unlock further performance and efficiency gains, specifically in the area of larger pieces of content. And so we did a lot of testing. We had specifically a lot of interest in what is the performance like with, several hundred kilobyte HTML files, and how would that be able to be cached and delivered efficiently. So yeah, and we really experienced great results with that. We were updating thousands of these blobs per second, and basically reaching in some of our testing environments, reaching basically network transfer limitations. That basically, we hit that, and basically you're using the network as fast as you can at that point with that type of data. So that kind of demonstrates the efficiency of the system.
Wow. So yeah, a few thousand. What size of machines are you operating on there?
I think these were like 16 core, 32 gigabyte machines. And we were actually taking advantage of uh, Akamai's Connected Cloud's block storage system. And some of the testing was to be able to really make sure that um, basically remote storage that wasn't attached was also able to continue to deliver that type of performance. And that system works really well with blob storage. One of the things that is an important part of this whole mechanism is Harper is definitely designed to be a heavily concurrent server system.
Uh-huh.
It's designed to, run multiple threads, fully utilize the cores, and that's also translates into I/O. Uh, you can have a lot of concurrent I/O operations that are taking place with blob storage. And the blob storage is really very focused on facilitating that and allowing heavy concurrency. And that allows you, like at the storage level, to build up deep queue depths, which um, ultimately help storage systems really operate at maximum efficiency.
Hmm. So as you're talking about concurrency, are you talking about concurrency on a single node here?
Yes, I am. Yeah, yeah. And obviously, Harper is designed to be a distributed system, so you also have the horizontal concurrency of running multiple nodes in a distributed fashion that further accelerates the ability to deliver a lot of content to a lot of users really quickly and in a local fashion, right?
So how does that work? Blob storage and kind of that synchronization layer that Harper has that's updating the data on other nodes. Any kind of concerns or performance things there, or have we really optimized there as well?
Yes, that's fully integrated into our replication system. And that's actually exactly what we were also testing with our recent load test, is ensuring that this all works smoothly with our replication system. These tests were run with a 4-node system. Um, but yes, this is fully integrated into replication, as well as even the streaming functionality of blobs. And so again, that means that you can potentially upload, a video on one server, and as that's uploading, it's actually replicating that data in real time in a stream. And so on another node, even, you can start accessing that video as it's being
Wow.
uploaded from one client to a server and then replicating, all in real time. So that's, again, one of the pieces of functionality that the blob streaming mechanism really unlocks, is that you don't have to wait for a single atomic transaction to finish to really be able to leverage this functionality.
And this is all out of the box, ready to go. Is there anything people should consider as they're building and looking to utilize Harper's blob storage?
Let's see here. I mean, there certainly is, uh, you do have to certainly be cognizant of the fact that you are dealing with something that's operating outside of the typical acid atomic paradigm of databases. Um, and so, being aware of that, and there's always the possibility that if media is being uploaded, that could be interrupted. You could have your upload interrupted. And so there's definitely, some things that you have to consider, just being able to handle those cases, because you're not actually able to abort a transaction as you would typically do. But generally, Harper provides good facilities for reporting those types of errors and giving you a chance to decide how you want to handle that. And there are actually potentially different ways, whether you could store truncated information or just simply delete everything associated with an
Hmm.
aborted upload. Right.
Okay. Okay. Thinking about scale, because like blob storage is really about like the larger data that we're dealing with here. I can imagine that we might need to use the sharding capabilities of Harper as well. How have we
Right.
optimized kind of the sharding to work with blobs as well?
Right, right. Yes, these do complement each other very well, and you're absolutely right that as you start uploading, as you start putting more and more larger chunks of data into a system, you can burn through storage pretty quickly. You can certainly, it certainly is possible to vertically scale in terms of storage on individual instances, but oftentimes there are significant advantages to distributing that data using sharding principles. And so, yeah, that does um, really complement blob storage. Um, it's all that is, of course, all integrated together. The replication system supports sharding, and so you very much can have a system where maybe you have 4 different shards, and that gives you the ability to really distribute that blob data across, and not have every server needing to store a huge amount of data. And then that really also can potentially unlock the ability to increase throughput as well. Distributing those writes across, 4 different shards can really provide the opportunity, if you have a lot of concurrent data that's being uploaded, you can distribute that data more efficiently. As far as like accessing that data, just the whole replication and distributed nature of Harper uh, really provides a lot of opportunities to, again, horizontally scale, allow users to access different Harper nodes, and in doing so, you can have tremendous amount of concurrent users accessing data, and doing so, just to go back to one of the other key reasons that people use Harper, is with that geographic distribution of the nodes. Those nodes are designed to be located close to users. With global load balancers, users are always accessing the closest Harper node, and being able to access both potentially metadata, HTML, and even images all in a regionally close server really unlocks the full low latency experience of building web pages and accessing those web pages and keeping content paints fast and efficient.
Awesome. It seems like there's a lot happening here with Blob. It's really well integrated into the whole stack that Harper offers.
Yeah, yeah.
That's great. So thinking about how this is kind of a stepping stone, like is there a larger vision here for Harper, and how does Blob Storage, is this just kind of the first of a few bits of functionality that builds towards a larger vision, or is this really meant to like stand alone and kind of be its a whole capability on its own?
I think we have a lot of things planned just in terms of furthering our the ease of use of building out tools and integrations for web development, integration with different web frameworks, providing more out-of-the-box functionality for different types of caching of web content, making it easier to cache HTML as well as any other type of content. And so, yeah, that very much fits in and builds on the Blob storage mechanism because we can directly leverage that as a way of doing this integrated caching. So yeah, looking forward towards later in the spring and summer, we definitely have a lot planned in terms of just continuing to provide a very easy and simple and direct path to being able to build web applications and have caching easily and smoothly integrated. So there's very little extra effort that's required to basically get enormous acceleration with your web applications.
Oh wow. So looking for that in like 4.6, is that going to be the
Yes.
next release here? Awesome. All right,
Yes,
I'm
yes,
guessing you've
that's
already
what we're
started
doing.
work on that.
Well, we're just wrapping up 4.5. So well, I guess you can say we've worked on it in the planning aspect of things, but yeah.
Awesome. Well, yeah, really appreciate all the great work that you and your team have done on Blob Storage and all the parts of Harper. Is there anything that you would like to leave us with before we close out today?
I think just generally looking at the 4.5 release, another thing that's kind of gone along with this is we've done a lot of work to generally improve observability and handling of um, how we deal with systems that are storing large amounts of data. Better observability around tracking how much data, how much storage is used, how much free space is available, and even adaptively responding to that. And so this actually makes it a lower administrative management effort because Harper is now capable of recognizing when free space is getting lower and potentially doing things like evicting less used or older entries from a cache adaptively based upon that. And that really gives you the freedom to actually be more aggressive about caching content because you don't have to like strictly make sure that your caching policy isn't going to exceed storage. You can kind of let the system adaptively respond to that. And so that really actually does complement Blob Storage as well as
Hmm.
because this is actually fitting into a holistic adaptive system for being able to handle large content with the storage capacity that's available to it.
Wow, so there's a lot more to this here. There's this adaptation part as well. Wow, we're really impressed by the work you guys have been doing. Well, thank you so much, Kris, for jumping on today and sharing a little bit about Blob Storage. I know it's very exciting. We had our PR person. She's like, "Can you call it 5.0?" And we're like, "Yeah, we'll call it. We'll save that one for another one." So what's interesting here is how big our releases can be, even when they are those like 4.4, 4.5 releases. So thank you for tuning in today, and we'll catch you on the next stream. Thanks, Kris.
Thank you so much. I really appreciate it.